Hi, in this lecture we want to test an hypothesis whether two samples have equal proportion. Alright, so to get started here, we will import the appropriate library and then we will go through some example so that we will understand how to use a Python proportion underscore z test to test for equality of two sample proportions. Alright, so from start model that start that proportion, we will import proportion underscore z test. So proportion underscore z test is what we will be using for testing the equality of proportions. Then, as usual, I like to import other libraries. We may use them or we may not. For example, pandas, matplotlib.pyplot, seaborn, and numpy. Alright, so the hypothesis is of the following. H0, P1 equal P2, so the two population proportion are the same, versus H1 that they are different. Alright, so the alternative could be a two-tailed test, just like in this particular case, or we could have a left tail or right tail test. In the case where we have a left tail test, we will use smaller for that. A right tail test larger, and a two-tailed test two-sided. Let's go through an example, and then we will use the data from the example to test the hypothesis. So in 2015, in a big city, on a sample of 1,000 drivers, 17% were driving while drunk. The following year, on a sample of 1,000 drivers, 21% were driving while drunk. And the question is, at 0.05 level of significance, is there any significant difference between the percent of drunk drivers in both samples? So all we are doing here, or we want to do, is test whether H0, P1 equal P2, the proportion are the same, versus the fact that they are different. But how do we set it up? All right, to use the proportion that z-test, I define what I call number of successes. So the successes are the number of cases drinking in each of the sample. So for the first sample, 1,000 drivers, 17% are drinking. So in total, it would be 170 people drinking. In the second sample, the successes are 1,000 drivers, 21% drinking. So we multiply 1,000 by 21%, we get 210. So we set up the number of successes in P.array 170 and 210. First sample, second sample. Then I set up the total sample size in each case. So in the first case is 1,000, in the second case 1,000. All right. Once we set up the number of successes and the total sample size, we are ready to use proportion underscore z-test. It takes as first parameter the number of successes. The second parameter is total sample size. And finally, the alternative. We want a two-sided test, two-tailed test. Like in this problem, we will use two-sided. And, we compute the test statistic. It will return a test statistic and a p-value. So we can print the test statistic here and print the p-value. Let's run this. All right. So the test statistic is negative 2.2799. And the p-value is 0.0226. At 0.05 level of significance, the p-value is less than 0.05, which means we will reject the null hypothesis and conclude that the proportions are different. Now, what if we wanted to do a left tail case? All right, it's the same problem. Now, same problem, 17% out of 1,000 drivers drinking while driving, 21% out of 1,000 drivers found drinking while driving. Now, the question is, at 0.05 level of significance, is the percent of drunk driver in 2015 significantly lower than that of the following year, 2016? So we write the hypothesis as A0 P1 equal P2 versus the fact that P1 is less than P2, significantly lower than. Again, number of successes is the same. Total sample size is the same. Everything else is the same except that the alternative, since we are doing a left tail test, we will have a smaller here. All right. Again, here the p-value is 0.01130, which is less than 0.05. So at 0.05 level of significance, we reject the null hypothesis and conclude that the proportion in sample 1 is less than in the second one, which makes sense. We see 1721. The test statistic confirm it here. All right. If we were to do a right tail test, same problem. Now the question is, at 0.05 level of significance, is the percent of drunk drivers in 2015 significantly higher than that of the following year? So we will set it A0 P1 equal P2, H1 P1 greater than P2. So for the problem, everything is the same, except that the alternative is larger because we are claiming that P1 greater than P2. If we run this, we get a p-value which is 0.9886, which is greater than 0.05, so we will fail to reject the null hypothesis. All right, which makes sense because we see 17 is not significantly greater than 21%. So this is how we carry out the proportion underscore z test, two-sample equality of proportion using Python. Thank you.